We need to show that 2 times derivative of y with respect to x plus y cube equals to 0 whenever xy squared equals to 1. So let's begin. So here in our problem, we are provided with a function which is written in its implicit form. That means xy squared equals to 1. What we'll do, let's label this as number 1. We are going to take the derivative on both sides with respect to x. So we have derivative with respect to x of xy squared, which will be equals to derivative with respect to x of 1. To find out the derivative of xy squared, we will have to use the product rule. So here we will have x multiplied to derivative with respect to x of y squared plus y squared times derivative with respect to x of x, which will be equals to the derivative of 1 with respect to x is 0. Now, finding out derivative of y squared, what we'll do, we'll use the power rule to get 2y. But since here we have a y instead of x, we'll have to use the chain rule. So we'll multiply it with derivative of y with respect to x plus y squared times, we know the derivative of x with respect to x, that simply equals to 1. Right. Now what we'll do, we want to make the coefficient of dy over dx with simply 2. So here we have an extra factors x and y, so we will divide throughout with x, y. That means we have 2 times dy over dx plus y squared divided by x, y. So this will be equals to 0. Right. Now what we do, we will multiply both numerator and denominator of the second term with y, which will make it 2 times dy divided by dx plus y cubed divided by xy squared. The whole reason we're doing this because we know that xy squared, this value is equals to 1. So that means we now have the 2 times derivative of y with respect to x plus y cubed divided by 1 equals to 0. We have used equation number 1. And finally, we get 2 times dy over dx plus y cubed equals to 0. So this is what we are asked to show.